Good evening, Rohit.
Okay, please understand.
Rahul.
Why? Because when, but for example, what is the answer here? All
Sumit,
are
good
ones.
evening.
Just listen here. All are ones. If that input comes,
Not audible. Am I audible to you? Good evening, Abhinav. Asif, refresh. Please comment to Asif to refresh. Good evening, Chaitanya. Robert, namaste. Good evening, Matthews, Vivek. Manjunath, good evening. I'm fine, Sushil. Good evening. Sadbhavana, Deep, Subham, Aditya, good evening. I'm good, Vivek. Good evening, Vivek. Yeah, location change today also. No. I am at my home only, my hometown and home place. Got yeah. In the multiplexer, we left with the last part. Let's start the class. Right. Good evening, Ruchita. Okay. So the last part of your multiplexer is implementation of higher order mux using lower order mux. I am having a higher order mux. Okay, so I am having some kind of lower order mux. I want to make another mux. That is, I have 2 by 1. How to make 4 by 1? That is the first example. What is the first example? How to make 4 by 1 using 2 by 1? Let's see here. So here you want to make 4 by 1. What happened? People are coming late today. Using 2 by 1. 1 use the process and again also. So Shil, 4 by 2 is a 2. Again you take this 2 and divide with 2 again. Okay, divide 4 with 2, you get 2. Take this 2 and divide with 2 again. So you get 1. Once you get 1, you stop this process. Okay, this will tell you number of multiplexers required. How many multiplexers are required for this process? 3 multiplexers are required. Is it clear how many multiplexers are required for this process? 3 multiplexers are required. Okay, so divide 4 with 2, you will get 2. Again, 2 you take it and divide with the same 2 again. You get 1. Once you get 1, you will stop it. All possibilities I will discuss in this class. Don't worry, this is the basic possibility we are discussing. Good evening, Sonam. Good evening, Amitabh. 2 plus 1 is 3. That much simple, Rishi. Divide 4 with 2, it will give you 2. Take this 2 and again divide with 2. 2 by 2 is 1. 2 plus 1 total is 3. This is the first line. Okay, total will be 3. Okay, so now listen here. Generally, if you take a 4 by 1 mux, good evening, Vasista, 4 by 1 mux, so how it will work? For first 2, S1 is 0 and the second 2, S1 is 1. Okay, so when S1 is 0, it will select I0, I1 based on S0. Okay, when S1 is 1, based on S0, 0 or 1, it will select I2, I3. Good evening, Saurabh. So, is this point clear? Now, I will make 4 by 1 mux using 2 by 1. Let's everybody please see here how to do that job. So, first stage, I will take 2 multiplexers. And the second stage, I will take 1 multiplexer. My job is done. So, now you connect its output to its input. Okay, now done. So this is 2 by 1. This is another 2 by 1. and this is 2 by 1. First stage you should take 2 multiplexers, second stage you should take 1 multiplexer. Good evening, Bhargavi. So now see here. So this is your, here you connect I0, I1, I2, I3, and here you should take a higher order, that is, and a lower order. 1 minute. So what is the higher order is S1 and the lower order is S0. Now you observe carefully. When S0 is S1 is 0, what happens in this figure? This is 0th position, this is first position, this is 0 position, this is first position, 0 position, first position, and this is your output Y. Whether it will work like a 4 by 1 marks or let us, okay, just assume or just visualize the condition. So you can see here, when S1 is 0, when S1 is 0, yes, when S1 is 0, then this part will be selected. Then S0 will decide based on I0 and I1, based on, sorry, when based on S0 0 or 1, your I0 or I1 will be selected. You see this table satisfied for this part or not? When S1 is 0, S0 will decide whether I0 or I1 will be selected and transferred to the output. Even here S0 is selected. S0 is common here and here. Even S0 is 0 here, 0 here. S1 will decide whether to take from this or this. Similarly, when S1 is 1, it will select the bottom multiplexer, that is these two, I2 and I3. So let's take one example so that you will understand properly. So for example, so let me take, for example, S1, S0 is equal to any random input I am giving. Just so let's assume S1 is 1, S0 is equal to 0. S1 is 1, S0 is equal to 0. Now listen, what happens, you understand. When S1 is 1, your output is connected to this one. You accepted or not? When S1 is 1, your output is connected to this one. Very good. Now, when S0 is 0, when S0 is 0, when S0 is 0, this is connected here. And here also S0 0, S0 is common for both of them. This will come up to here. That is I0 will come here and I2 will come here. But this fellow is 1. Because of this I2 will come in the output, but not I0. You understand? Both will come up to this. Then this S1 will select this I2 and give it to the output. Okay, so you can understand, you can visualize the switching. This I2 is transferred to the output based on the inputs 1 0. Similarly, you give 1 1, I3 will come 0 1, I1 will come 0 0 will give you I0. This is how you can implement one multiplexer using another multiplexer. So you have 2 by 1, you made 4 by 1, but you need extra multiplexer here. Don't assume 2 plus 2 is 4, sir, so I can make it like that. So if it is clear, I can move further. Please, 1 minute. In the today's class, just remind me, I told one wrong in the, adder problem. Okay, worst case delay. In the doubt session, I gave one wrong answer. Okay, I will make the correction at the end of the class. So yeah, for the delay only. So just remind me, I will make it. Okay, at the end of the class. I don't want to disturb the flow. So at the end of the class, we'll do this. 2 students gave me that correction. I'm very thankful for them. Ruchita and Pupul, both of them have given that. In message, I checked it. Yes. Okay. So thank you. So please remind me at the end of the class. So let's move further. Now, how to make 8 by 1? How to make 8 by 1 using 2 by 1? So divide 8 with 2. Now you will understand the process properly. 8 you divide with 2, you will get 4. Take this 4, divide with again 2. Why 2? You need, because you are having 2 by 1. So 4 by 2 is 2. Again, take this 2, divide with 2. You will end up with 1. You stop this process. 4 plus 2 plus 1. What is the answer? 7. So now no need to do this. The simple formula I will be giving you is, if you want to implement 2 power n by 1 mux using 2 by 1 mux. Okay. So then our answer is very simple. How many multiplexers are required is 2 power n minus 1. So how many multiplexers are required to implement 2 power n by 1 using 2 by 1? It is 2 power n minus 1. 2 power n. Okay, here 8 minus 1. Okay, very good. So this is only for using 2 by 1. Suppose you want to make any multiplexer using any multiplexer, what to do? Let us see. Before that, one more. Implement 8 by 1 mux using 4 by 1 mux. So you have 8, you want you have 4, you want to make it 8. So let's see how to do this problem. I want to make 8 by 1 using what is that available 4 by 1. Divide 8 with 4. What is the answer? What happened here? 2. Then again divide with 2 with 4. 2 by 4 is 0.5. 0.5 multiplexer not possible. You should take one multiplexer. You cannot have half multiplexer now. Anything less than or equal to 1, you should take it as a 1 multiplexer only. So total multiplexers are how many? 2 plus 1, 3. So how many multiplexers are required here? 3. But when it is not a proper one, then there is one meaning for that. I will come to that. I will come back and explain that meaning. Don't worry. So let me make this part. Right. So let's make it in the fresh slide. Okay. So listen. Now please see. Try to do that. So 8 by 1 multiplexer contains 3 selection inputs. What are the 3 selection inputs? Are S2, S1, S0. Okay. What about your Y when S2, S1, S0 are 0, 0 to 1, 1? It will be Y0 to Y3. During this period, what are the outputs you will be getting? Y4 to Y7 will be selected. I hope you know this. Okay. Yes or no? For the first one, Y0, second one, Y1, Y2, Y3, Y4, Y5, Y6, Y7. If you want, I can write that format also. 1 minute. You can say I0 if you want. What is your Y? It is I0. Okay. I1, second case I2, third case I3, I4, I5, I6, and I7. Okay. So here again, your observation is important. For the first 4, what is S2? So for the second 4, what is S2? Second 4, what is your S2 is 1. Very good. So other part you see it is 0, 0, 0, 1, 1, 0, 1, 1. It is 0, 0, 0, 1, 1, 0, 1, 1. It is same as the 4 by 1 mux combination. So let's take two 4 by 1 multiplexers. Let's make it little colorful. Okay. You have two 4x1 multiplexers. At the output, you should take one more 4x1 multiplexer. That is what you got it in the table. No? 2 plus 1 is 3. So now listen here. 0, 1, 2, 3. 0, 1, 2, 3. So 0, 1, 2, 3. It is a 4x1 multiplexer. So now listen here. It is having two inputs. Now see here. Please listen here. Here you give S2, S1, S0. Now you give here S1 and S0. That is these two. Here also you can give S1, S0. They can be 0, 0, 0, 1, 1, 0, 1, 1. They will select I0 to I3. And here I4 to I7. Okay. Now please listen. I should select S2. When S2 is 0, first multiplexer is to be selected. When S2 is 1, second multiplexer is to be selected. I have only two logics here. But my mux is 4x1. So can I say instead of 4x1, you can do this job with 2x1? Yes or no? Otherwise, you can do like this. You can do like this. You take it as a higher order and lower order. Okay. Then if you take it as a higher order and lower order, so you can make it as a ground. Ground means permanently 0. And here you connect your S2. So S2 can be 0, 1. When it is 0, 0, it will select this line. When it is 0, 1, it will select this line. I hope you understand. Okay, because here 4 inputs are there, but 4 inputs are not required for me. 2 inputs are only required. So you can say this job can be done by a simple 2x1 mux. 4x1 is not originally required here. If you have 2x1 with S2 as the selection input, that can also do your job. Is it okay? This third multiplexer is need not be like this. It can be selected like this. Or you can also do like this. I'm writing in the next slide because of the space availability. Just 1 minute. So you take 4x1. For that third multiplexer, you can do n number of ways. Okay. So here it is the higher order, it is the lower order. In that, suppose I grounded this now, you ground this one. Then this is permanently 0. Then this you connect S2, no problem. S2 can be 0, 1. Okay, then it will select. We should use 0 and second line instead of 0 and first line. Okay, here it is 0, 0, 1, 0 are used based on S2. Okay, you understand that or not? Similarly, 1, 0 means here higher order, lower order. That is the meaning. Okay, of your selection inputs. You join both the selection inputs and give it to S2. Then S2 is 0, it can be 0, 0. When S2 is 1, it will be 1, 1. So you can use these two connections to the next two multiplexers. So it is not this way. You can do different ways here. Okay, you can connect inverter between them. Your wish. I just gave one example here. Is this example clear? You have two selection inputs. One selection line is made permanently 0. And for the other selection line, I have made S2. When S2 is 0, it will select the top. When S2 is 1, it will select the bottom. That will make your job complete. But if this clear for everybody, I will move further. If it is clear for everybody, I will move further. Okay, very good. So listen here, one small point. Okay, what does it mean? I have 4 inputs in the mux, but 4 are not required. Only 2 are required. 2 by 1 mux is required. Every time you need not draw the figure in your exam. You see that point is indirectly available in this. How it is available, sir? It is 8 by 4. It is 8 by 4, 2 and 2 by 4. When it is not an integer, when it is not exactly 1, it has one meaning. This is not 4 by 4. Now, what is this integer? What is the numerator is 2. What does it means? In the last multiplexers, 4 inputs are there. 4 are not used. Only 2 will be used. Okay, that's all. That's all. So now you can see, you can write 3 4 by 1s may be required, or to make this 8 by 1, you can also say another possible answer is 2 4 by 1s and 1 2 by 1. Okay, 1 2 by 1, 1 2 by 1 enough for last stage. For last stage, 1 2 by 1 is enough. Okay, this numerator is 2. That is the way you can answer the question. This is also okay. This is also okay. 2 4 by 1s and 1 2 by 1 is sufficient. Is it okay, everybody? Very good. What happened, Saurav? सर क्या होता है अगर 2 की जगह 3 होता? Actually, you can do with 3 4 by 1s, or another answer is 2 4 by 1s and 1 2 by 1, depends on your availability. Why to waste 4 by 1? If 2 4 by 1s are doing my job and 1 2 by 1 is doing my job, take this instead of taking 3 4 by 1s, because 4 by 1 requires more gates compared to 2 by 1s. So if examiner give you options में only 4 by 1s, then it is 3 only. If we give the optimum solution, it will be 2 4 by 1s, 1 2 by 1. Okay, generally he will say, he don't say anything, you assume this is your answer in the exam. Okay, how many 4 by 1s are required to make the 8 by 1 marks? Answer is 3 only. So let's do all of them. Let's start. Okay, so the first question here, what is that? 16 using 4. So what to do? Divide 16 by 4, you will get 4. Then 4 by 4, you will get 1. 4 plus 1, 5 is the answer. Okay, next, this one. Divide 256 by 16, you will get 16. Yes, 16 by 16, you will get 1. How many multiplexers are required is 70. So here your answer is 70. Next, you want to do this, you can do. Divide 256 with 8. First this one with this one. Okay, then you will get 32. Be careful, be careful. 32 divided by 8. 4. 4 by 8, you should take 1. Stop. Okay, 37 is the answer, no doubt. Whenever you are not ending with perfect 1, then what I told, your numerator is having some meaning. What does it mean? Please listen here. You can say your answer is 36 8 by 1, sorry, one feasible answer is 37 8 by 1s, okay, or 36 8 by 1 and 1. What is that? Numerator is 4 now, 4 by 1. Enough for last stage. Okay. So please understand this is 4. That's why we are taking this. You understand here this, if you go this order, before this you have 32. Before this, how many inputs are there? 4 inputs are there. So 4 by 1 is enough. Here 32 inputs are there. That's why 4 8 by 1s are taken. 4 8s are 32. Okay, here 4 inputs are there. So for this stage, we take only, what is that? 4 by 1. That will be sufficient. Both are right answers. That's what I want to do. Can you do these two as a practice? Yeah, first one is 9 and second one something will come. So you can check this numerator will tell you what is the marks required in the last stage optimum. Okay, done. So you can do very well. So this is also one of the frequently occurring model. So that will complete your marks. That will complete your marks. Okay. So now the next part we are going to discuss is, yeah, demultiplexer. We covered all the possible models in the mux. Okay, please do enough practice. Anything given in the mux, you will be able to do it. Thank you, Sushil. Right, all the possible delay is given, universal gate, okay, how to implement, how to identify, how to make one mux using any mux, all the possible models are there. So then now the next one is demultiplexer. So let's go to the next one, demux. So just it will do reverse part of mux. Whatever we have done for mux, multiple input, single output. So demux will do the reverse part of the mux. So reverse part of the mux. Let's see what is that reverse part of the mux. How you get 3 by 4? If 3 by 4 comes anywhere, okay, you are generally dividing some 2 power m by 2 power n. You will get 2 power m minus n, which is always an even number only. That is a multiple of 2 only. Okay. So let's start this one. So demux. Demux is a combinational circuit, same as mux, but reverse. Mux is multiple input, single output. What about demux? Demux is single input, multiple output. Mux is converging multiple to single, but demux is diverging. It will be represented like this. Okay. So you will be having a single input, you will be giving it, okay, to n 2 power n number of inputs. This input can be transferred to any one of these 2 power n that will be selected by selection lines. You can also do like this. You can represent like this also, demux. So you are having 2 power n outputs and 1 input and n selection lines. Okay. So same, this is your 2 power, 1 is to 1 by 2 power n mux. Okay. So you will be having n selection inputs, 2 power n output lines. So based on the selection lines, input can be given to any way. This input can be transferred to this fellow, or any fellow. Okay. So mux and demux. Mux is generally you can use it as a transmitter at the transmitting end, multiple sources, single channel. At the receiving end, single channel, multiple receivers. That is done by demultiplexer. So let's see what is there in the demux. One of the disadvantages here is generally demux cannot be used for implementing logic functions since only one input. Because it is having only one input line, it is not directly used as a implementation of logic functions. Like mux, you cannot do this. Okay, but small alteration if you do, you will be able to do for this also. That we will see next. So firstly, basic 1/2 mux, 1/2 demux. What is 1/2 demux? You have a single input, and how many outputs you are having? 2 output lines, Y0, Y1. Okay, so now so based on the selection input, your selection input can be 0 or 1. Your Y0 and Y1, if it is selection input is 0, this input is given to Y0. Or when selection input is 1, input is given to Y1. Okay, so now you see based on the selection input, it can be 0 or 1. When it is 0, it will be your input will be transferred to I, will be transferred to Y0. Similarly, when it is 1, your input I will be transferred to Y0. This is how you can make 1/2 demux. Everybody accepted or not? Internal circuit of the demux. This is in the box. Okay, so let's do the one little higher order. 1/4 demux. 1 minute. Both Y0, Y0 and Y1. Yeah, just you can see Sushil. Yeah, what's the doubt? When S0 is 0, when S is 0, then when the selection line is 0, this I will be coming to Y0. Okay, is it clear, Sushil? When S is 0, I will come to Y0. When S is 1, I will come to Y1. That's all. Same, when S is 0, this fellow will be 1, I into 1 is I. Okay, when S is 1, this will be 1 into I, Y1 will be. Right. So let's make 1/4 demux. Thank you. So here you have only one input. How many outputs are there? 4 outputs are there. So 2 selection inputs. So let me take the selection lines S1, S0. So here Y0, Y1, Y2, Y3. When selection lines are 0, 0, 0, 1, 1, 0, 1, 1. Okay, when it is 0, 0, Y0 will get the input I. I can be, I is just information I. It can be 0 or 1. Okay, whatever you keep it here, that will come. And 0, 0, 0, I0, all zeros. This will be I. Okay, so now let's make this. Let's make implementation of this. So how to make it? When S1 and S0, okay. So when S1, S0 are 0, 0, your I will be given to Y0. When S1, S0 are 0, 1, your I will be given to Y1. When they are 1, 0, your I will be given to Y2. So when they are 1, 1, I will be given to Y3. Okay, that's all. So based on S1 and S0, it will select if it is 0, 0, 1, 1. Based on that, it will select. If you want, I can make. So is it clear the internal structure of your mux, demux? Why not? Which gate, Manoj? Why not OR gate? OR gate is having a problem. Here, your job is to transfer I. Please understand. To transfer I when it is only 1, 1. When you keep 1, 1 here, if you use OR gate, 1 plus anything is 1. Okay, but what I want to transfer is not 1. I want to transfer I. What is the output of the OR AND gate here? 1 into 1 into I. What is the answer? I. Okay, so if based on your I, you will get it here. Similarly, for 1, 0, whenever you keep 1, 0, okay, or where is that? 1, 0. If you keep 1 here, if you keep 0 here, 0 bar will be 1, and these two will transfer I, like that. So that job can be done by AND gate only, not OR gate. Enabling and disabling. Okay, whenever one is given, it will be enabled and it will transfer the other input. Okay, if you want, you can make by NAND gates, but active low will come. Like that, you can make it. Bubbles can be taken and you can make it. So if you don't want 1, you want output by 0, you can manage like that. Okay, if you want to make it with OR gate, you take here. Whenever a particular combination occurs, it should be 0. Like that, you can design. Okay, that is called active low, where here these combinations will also be inverted. So now 1 minute, I have a small, yeah. Just 1 minute. I want to take one small screenshot. So that our time will be saved later in one problem. Smart work is always required, right? Okay, done. So let's move. Okay, here in the demugs, you don't have much kind of problems. The maximum they will ask you one kind of problem, that is how to make one demugs using another demugs. Maximum they will ask you that. So let's see how to do that. One eye is missing. Which eye? Where, Bharati? It is there. Okay, let me type in. Is it visible for you? Why not input I is there? Maybe it is not. It's there. Okay. So let's move. Okay. So the next part, how to implement one demux using another demux. Only this can be asked in this exam. Okay, I mean exam. I mean in this from demux. Okay. So listen here. So very simple. Suppose you want to make 1 by 4 using 1 by 2. Here process is very much easy. Same as your mux only. Divide 4 with 2. 2 will come. 2 with 2. 1 will come. 2 plus 1 is the answer. But the order is reverse. There high to low. Here low to high. That's the difference. Otherwise it is same. There high to low, here low to high, otherwise it is same as the previous case. So here you will be having the reverse order, that is low and followed by high. So now just it will be nothing but reverse figure of mux implementation. Yes, mirror image you can see. It is 1 by 2, it is 1 by 2, it is 1 by 2. So here let me give you that what we discussed earlier, S1 S0 can be 0 0 0 1 1 0 1 1. Okay, so here your y0 will be I, here y1 will be transferred with I, y2 will be I, and last case y3 will be transferred with I. You understand that or not? Already we discussed. So first case S1 is 0 and second case your S1 is 1. So when S1 is 0, your first that what I should be given to either y0 or y1. Otherwise, it should be given to y2, y3. Same process. So S1 and S0. So I will be given to, when S1 is 0, I comes here and this will decide whether this or this. Similarly, when S1 is 1, I comes here, S0 will decide whether it is 0 here or here. So this will tell you Y0, Y1, Y2, Y3. Okay. So now listen here. You have any doubt, just check it if you want. For example, S1, S0 is equal to 1, 0. Okay. So I keep S1 is 1, S0 is 0. So if it is 1, this line will come here. I will come up to this. I will not come here. And S0 is 0. So this line will come here. Even it comes here, it is 0 only. But it comes here, it S0 is 0. Now this line will come to here. What is that? I will be coming here. Remaining all will be 0. So Y2 is getting your I. You understand? It is just you observe this figure and this figure. Are they mirror image or not? This figure and your this figure. Are they mirror image to each other? Just there it reverse, just S0 and S1 here, S1, S0. Otherwise, it is same. Process is also same. So can I say to implement any demux using any demux, whatever the process we followed earlier for the mux, can I repeat the same here also? I mean, for any to any. Let's do those examples so that. So here, what is the answer? This is 16 and 4 na. So divide 16 by 4. You will get 4. 4 by 4. You will get 1. 4 plus 1. Here order is reverse. Low to high. Similarly here. Divide 256 with 16. You will get 16. Divide with 16 plus 1. Here also order is reverse. 17. Okay. So similarly here. 256 you divide with 8. Okay, 32 will come. Story same. 32 you divide with 8. You will get 4. 4 you divide with 8. 1 will come. 36 and plus 1, 37 is the answer. But what is the condition I told? When the numerator is not a perfect, when the numerator is not a perfect, I mean, when it is not a perfect one, okay, then what to do? You can say, I already told you, you can make it with 36. Okay, you can say your answer is 37 8 by 1 is required, or you use 36 8 by 1 and one comment. Okay, okay. We are in the mux mode only. Yeah. 37 1 by 8. You can say 36 1 by 8 and 1. What is the numerator? 4. So 1 by 4. Okay, is enough. Is enough for, is enough for which stage? Yeah, first stage, not last. Very good, Rishi. It is not last because here the order is reverse. Okay, in the marks it is last. Here it is first. Okay, done. So let's move further. What's happening, Sushil? Okay, let's move further. Some 921, some different numbers are coming. Right. So the next part we are going to discuss is decoder and encoder. Okay, okay. You are saying the next two answers. Okay, okay, got it. Decoder and encoder. So listen here. Decoder is a combinational circuit. Encoder is also a combinational circuit which contains many inputs and many outputs in general. They are used for code generation and code conversion. Please listen here. One simple example I want to give you. Suppose you have a transmitter, you are sending this data, and you have a receiver. This fellow is receiving the data. Okay, when you are sending the data, this fellow is receiving the data. You don't want only this fellow want to receive the data. Other person, okay, should not receive this data. Even he receive, he should not understand the data. Then what to do? You should not understand the data at the other end. So what you do is you encrypt or encode the data. Okay, you will encrypt or encode the data and send it. At the receiver, you decrypt or decode. Okay, so how you encrypt? There can be n number of ways. For example, your name is there. Who commented last? Vivek is there. So Vivek. So I made Vivek as a 52569. Some code, random code is there. For that code generation, I have some concept. Okay. Then it will send. Okay. But this fellow may not be able to understand. At the receiver, you will have corresponding decoder. That decoder input may you give 52569. He will tell the output may it will give it as Vivek. Okay, so you can design your own encoder, you can design your own decoder. Corresponding decoder should be present for the encoder to get your data transmission properly and understand the data properly. Is it clear? If you go to higher level in your computer science, it is the encryption, decryption, network security, everything will come into picture. So now, so here what we are discussing in our digital part is simple binary encoder and binary decoder. You may give the binary input or you may give the decimal input. It may do one form to another form. Okay. So now first let's see how your decoders will be. Generally decoders are used for converting the given. It will have generally here n inputs and not compulsory but maximum 2 power n outputs. And one extra signal is there here called enable. So n by 2 power n decoder. This is the structure. I have a block diagram of your n by 2 power n decoder. N inputs and 2 power n outputs. We'll take one example and check it. Don't worry. Similarly, you can have encoder. Encoder is exactly reverse of this. Okay, here you give n inputs, you get 2 power n, binary to octal decimal like that. Here you give 2 power n inputs. Okay, if you may be giving the decimal input, hexadecimal input, it may be converting into binary or it is generating the code here. Okay, in your computer also for address selection, okay, and interrupts connection, you will be using these encoders and the decoders. Okay, when I explain, first let me explain it, then I can give you the utility of this. So first let me explain how this decoder will work and all those things. So let's move. No, just wait. Saurav, just wait. You can modify and if you can make it similar to that if you want. Which language here? Let me explain the decoder first, then you can understand the terminology. Don't worry. It is used for code generation. That is, it will convert. Okay, let me, when we explain this encoder, then you will understand. Don't worry. Just wait for some time. So your definitions will be like that. Don't worry about it much. Decoder. Yes, that's what I'm saying. Now I will explain it. When I already explained this, again I will explain when we discuss the encoder part again. Don't worry. So for decoder, so the first one I want to discuss is 1/2 decoder. So let's start with the decoder. Okay, so okay, listen. First we are going to discuss is 1/2 decoder. That is, you have one input. It can be named as anything. You can name A, B, C, anything, and you have two outputs. Why not? And why? And here you have one more input called enabling. Okay, so when here 1 minute, why not and why one? When A is 0, here you will get 1, here you will get 1. One more is important here, enable. I will explain, don't worry, just wait. Okay, you see this figure. Now you observe here. When enable is 0, A can be anything. I want to implement like that. When enable is 0, A can be anything. Your y0, y1 both will be zeros. Okay. When enable is 1, then based on A can be 0 or 1. When A is 0, okay, A will select here. A is 0, y0 will be equal to 1. When A is 1, y1 will be equal to 1. So you can say this is nothing but A, and here it is enable and y0, y1. Check it. When enable is 0, here 1 minute. You can say this is your enable, okay, and this is your A. Can you tell me whether it is correct or not? When A is 0, okay, when enable is 0, this AND gate input is 0. If one of the input to the AND gate is 0, both are zeros. When enable is 1, then A will decide whether A is 0, then you will get here 1. When A is 1, you will get here. Is it okay? Right. Now, listen here. You see, if this enable is not there, simple inverter can do this job. Will you accept it or not? If you have an inverter like this, A, okay, and you take y0, y1. When a is 0, y0 is equal to 1. When a is 1, y0 is y1 is equal to 1. So a simple inverter can work like a 1/2 decoder, but without enable. That's the simply 1/2 decoder is nothing but a 1/2 decoder is nothing but a 1/2 decoder is nothing but a inverter with extra AND gate. Is it okay, everybody? Is it okay, everybody? Very good. So let's move further. The next one we are discussing is 2/4 encoder. Sorry, 2/4 decoder. Okay. So now 1 minute. It contains only one enable input. Two inputs A and B and four outputs. What are the four outputs we will be having? Y0, Y1, Y2, Y3. Here also you have enable input. Okay. It can be 0 or 1. When enable is 0, your AB can be anything. All will be zeros. When enable is 1, but that is for the remaining 4. Okay. AB will select, when AB is 0, 0, it will select Y0, Y1, Y2, Y3. When AB is 0, 0, this one, 1, 0, okay, 1. I will make it little proper so that you can understand better. Now you see, now you observe the table. When enable is 0, AB can be anything, all are zeros. When enable is 1, AB will decide which output will be 1. Y0 is 1 or Y1 is 1, Y2 is 1 or Y3 is 1. Okay, that is indirectly you understand it is decoding the code. How it is decoding the code? When it is 1, 1, it is making third line is equal to 1. It is saying that 3. Okay, if it is 1, 0, it is making second line is equal to 1. It is saying that it is 2. Similarly, you can have a 3 to 8 decoder. When you give 1, 1, 1, seventh line will be equal to that 7 will be equal to 1. When you give 1, 1, 0, 6 will be made equal to 1. The line position, that particular will be made equal to 1. You may connect some 7 segment display to display the results if you want. Now listen, is it clear up to this? Right. So I made that figure. You observe whether it is correct or not. It saved our time. Yes. Right, Manjunath. You can say binary to base 4 here because you have only 4. You can say binary to base 4. Binary to decimal is also correct. You can have 4 to 10 decoder also, no problem. So is this everybody clear or not? You observe, when enable is 0, all will be zeros. When enable is 1, AB will decide. AB will decide whether it is 0, 0, Y0, 0, 1, Y1, 1, 0, Y2, 1, 1, Y2. Now, carefully observe one thing. Is this figure 1/4 DMUX figure and your 2/4 decoder figure same or different? Same figure, but you are using in a different way. There I use the names S1, S0 and I. Here I used the names A, B, enable. There my I is the input, A, B are the selection lines. Only the way you are using is different, but the internal circuit is same here. Okay, so you can say like this: if S1 S not replaced by AB, your I is replaced by enable, then okay, Dmux will work like decoder. Dmux will work like a decoder. Dmux and decoder both are internally same only. Only difference is their names are different. Only the way you are using is different. Otherwise, it is same. Is it clear, everybody? For binary, at least. Okay, let's move further. Since which case here, Aditya? Here input is AB. The way you are taking the inputs are different, Aditya. Inputs are AB and enable is your input. There. There I here enable. That's all. Not 1 by 2 also it will work, but 1 by 2 is simple. That's why I have not explained. Same figure I copy paste. Na? You understand here? Their I job is done by enable. This can be 0 or 1, doesn't matter. If it is 0, it will be disabled. There also, if it is 0, all zeros only comes now. Okay. If I is 0, you get all zeros only. Same thing happens. But here to enable, we generally make 1 and use it. Okay. If you disable also, it will work same. That's what. Please listen. In the Dmux also, input can be 0 or 1. Similarly, here also enable can be 0 or 1. If enable is 0, we say that here the name changes. It is disabled, all are zeros. But there, your data is 0, output is 0. Okay. Here I job and enable job are same. It can be 0 or 1, doesn't matter. If it is 0, it will not. Same rule there also. If I is 0, all zeros will come now. So for example, you take this table. In this table, if I is 0, what happens? That's all. So what I want to say is, since internal structure of decoder is same as Dmux. Okay, same as Dmux. Okay, you can say your 2 by 4 decoder is also called 2 by 4 Dmux. You may say, sir, 1 by 4, 1 by 4. No, just wait. Let me clear this point properly. Sometimes your examiner will tell you like this: implement the following problem using 2 by 4 Dmux. Then you in your mind you will get the doubt. Sir, it is 1 by 4 na Dmux. Why he is saying 2 by 4? That means you should take 2 inputs, 4 outputs format. That is nothing but use it as a decoder. Okay. Please understand, if examiner say implement the following circuit using 2 by 4 Dmux or 3 by 8 Dmux, then you will immediately get the doubt. Sir, Dmux is 1 by 4 and 1 by 8. Why he is saying 3 by 8? When he used this kind of terminology, what does it mean? Use Dmux as a decoder. Okay. When you use the terminology of n is to 2 power n, whether it is used as the name suffix can be Dmux or decoder, doesn't matter, it is the same. Okay. Right. So here the first question comes to you is implement 3 to 8 decoder using 2 by 4 decoder. No, Saurav, enable can be active high and active low also. I'll come to that point. Okay. It can be zero, it may work. Okay. If you use a simple inverter at the enable, it will do the reverse job. So it depends on the circuit. Where active high is good, where active low is good, everything we discussed, don't worry. Just wait for some time. Today itself. Now, where we are? Okay. So 2 by 4 decoder is also called as 2 by 4 DMUX. Okay. Now implement 3 by 8 decoder using 2 by 4 decoder. So here also story same 3 to 8 using 2 by 4. What is you are having? Rule is same as DMUX because it is circuit is same as DMUX now. So I'm not doing all those problems again, but 8 by 4. What is the answer? Then 2 by 4 is 1. So how many are required is 3. 3 decoders are required. Okay, first is 1, next is 2. So now take forget about your enable for some time. I mean to make the analysis. So during this period, Y0 to Y3 will be selected. During this period, Y4 to Y7 is selected. Okay, is this part everybody accepted or not? Your enable is required, definitely required. Okay, I'm not writing it to make the analysis simple. That's it. Okay, very good. Now during this period it is 1 and during this period it is 0. So I will use the same logic which we have used for implementing DMUX, the same circuit in fact. Okay. So what to do here? You take 4 by, sorry, what is the name terminology you are using? 2 by 4. Tomorrow we will finish the combinational and I will be starting the sequential circuits part. You can give the names Y0, Y1, Y2, Y3. Okay. Tomorrow means Monday only. Tomorrow is Sunday. Yes, yes, yes. Tomorrow means next class. So you don't forget your Sunday. Yes or no? Yes. Have fun, Robert, but safe fun. Okay. Yeah, part 2 is from July 1st. It will be continuation only. Today only I made the schedule. Maybe it might be launched already, or maybe tomorrow or day after tomorrow it will launch. Don't worry. No, it is launched as part 2 due to some technical. I mean, some when we made the schedule, some error has occurred. Up to July 1st, I made initial. It is continuation only. Last date is your August 8th. Including microprocessor. Okay. Now it is same story. Here you have one enable input. Here you need to higher order and lower order. If you take you make this 0 and A. So it is always 0. A can be 0. Okay. Then that's all. So now you understand when A is 0, it will select the first decoder. When A is 1, it will select the second decoder. Everybody accepted or not? Is it okay? So I want to take one more thing here. Yes, you are exactly correct, Rishi. I will do that only. Just okay. So instead of this, as Rishi told, you can use 1 by 2 also. So let's do that also. So here you use 1 by 2. I think when I went to this, yeah, during my MTech admissions, when I went to IIT Delhi, they asked me this question: how to make, I think, 3 by 8 only. You can do like this, no problem. Okay. Or if you want, you can also do like this. That's all. Okay. You can use 1 by 2. You can use inverter also, because the inverter without enable. What is the difference? You understand now? Here you have enable. Control is there in your hand to totally disable it. But here you don't have that control. Okay. So here you can say your answer is 3 2 by 4s or 2 2 by 4 and 1 1 by 2. Why 1 by 2? Because this numerator is 2. You will get 2. Okay. Enough. for which days? Yes, for the first stage. Okay, because the order is reversed here. Okay, you understand here 1 by 2 are inverter because your 1 by 2 can be replaced by inverter. I told you. I'm giving you small homework because Sunday you try this. IES conventional, it is already given also. Implement 4 by 16 using 2 by. I hope you can do this. It's not a difficult task. If you're ready, I can move to the next one. So, yeah, you can ask Abhinit why you are saying it. You can ask happily. So here, if you want to make using this and this, the story is same or not? Take 16 by 4, you will get 4. 4 by 4, 1. Okay. So what is the total is 5. So similarly here, 256, I'm not doing all, only just 2 examples. 8, 32, 32 by 8, 4, 4 by 8, 1, that is 37. Here you can say your answer is 37, 328 or 36, 328 and 1. What is that? What is the numerator here? 2 by 4. Enough for first stage. Okay. So what is the Abhinit doubt? Everybody clear with this? Any doubts? Please ask. 1 by 2 decoder also acting buffer when we are saying that 1 by 2 only be replaced by inverter. How it is acting like buffer? I didn't get you. It is a single. Please listen, Abhinit. Yeah. Yes. Use this here. A. Okay, you are getting A. You should not say it as a buffer. Okay, output A, input A. You should not say it as a buffer because you are not doing any. There is no circuit here. In one way, technically, you say both are same, so you can say it is a buffer. Okay, here it is A bar. It is inversion and same. Both are available here. Okay. So buffer is different case where your output is same as the input. Here also it is doing the same job, but no circuit explicitly available. Is it clear, Abhinit? Yes, depending on the implementation, delay will be there, or input impedance size, all so many different cases are. Okay, so now let's do some problems because some starting say today. Enough for first stage means in the first stage instead of 3 by 8 you can take a small 2 by 4 which is a small person compared to 3 by 8. That is the meaning. हमको 3 by 8 नहीं चाहिए 2 by 4 से काम हो जाएगा. You need not require 3 by 8. For me 2 by 4 is enough. I don't need 8 outputs. I need 4 output to decoder. Give me that, it is enough for me. So let's do few problems. So the previous gate question comes here. Where is that question? 1 minute, I am just checking the slide. Yes, got it. So I have given this in the DPP also. Can you tell me? Let's do this. I will conduct the poll. Just get ready. Get ready, guys. Ready? Shall I start the poll? This one is a tri-state buffer. If you want, I can explain little about the buffer because we have not discussed. Please listen. Listen, please. What is tri-state buffer? It is X and Y. Okay. When control input is 0, your Y will be Z. When control input is 1, Y will be X. X can be 0 or 1. So why it is called tri-state? Okay, why it is called tri-state? It is having 3 states. Tri means 3 states. What are they? Your X can be 0 or 1, not 2 states. X can be 0. Whatever you have in the X, that can come in the output. X is 0, output can be 0. X is 1, output can be 1. Another possibility is Z. What is Z? It is called high impedance. High impedance, or you can say it is equal to open circuit. What is the use of open circuit, sir? Physically buffer is connected, but electrically it is equal to disconnected. So that for one single line, you can connect more number of inputs directly by enabling only one at a time. Out of this, suppose these 3 are disabled, only this fellow will come in the output. Similarly, if you disable the last one, only third fellow will come in the output. That is what we call tri-state buffer. When it is a control input is, or when its enable input is made equal to 0, you can say C or enable, whatever may be. Its name can be C or enable. You take it as enable if you want. When enable input is 0 or 1, it will be in the, depending on enable 0 or 1, it will do its job. When enable is 0, it will be in the high impedance state. What is the use of it? To implement common bus. Common bus means the same, for same line, all devices are connected, but you activate one at a time. People, what happened here? This much time I have explained why it is called 3 state. You are asking the same question. There is a third state now. This is your third state. You understand? So X can be 0 or 1, 2 states, and high impedance also, third state. That's why it is called tri-state. Is it clear now? Or if you have doubt, ask me, no problem. Because it may be relatively new for you. Ask me if you have doubt. What happened here? No comments are coming. Is it okay? Clear? Open circuit or high impedance? Google, which branch you are, please? Any CSC people are there? Electrical only. So very high impedance means you can replace it with open circuit or not. Open circuit ka impedance kitna bhai? Infinite. Open circuit means infinite impedance. So like that, when this control is made equal to 1, your transistor may be internally, maybe some transistor may be there that will act like a open circuit by driving into cutoff. That is the meaning of high impedance state or open circuit. Okay, so why it is called tri-state buffer? It is having three states. When this enable is equal to 1, your input will be transferred to output. Okay, as it is, that is your input 0, you get 0. Input is 1, you get 1. Okay, input is 0, you get 0. Input is 1, you get 1. So that is 2 states. And when enable is zero, it will be driven into high impedance or open circuit, that is physically connected, electrically disconnected. Ganesh, please wait for the other people to understand, because they may be relatively new to this tri-state buffer. Is it clear? Everybody now? Okay. So it can be different tri-state buffers are possible, man. This can be, let me write, because anyway it came. So it can be like this. It can be like this also. Okay. See, what are the three states? It is 0, 1 and Z. What is Z? Z means high impedance state. Is it okay? This is your X. Your Y can be equal to 0 or 1 based on your input, and also Z. Three states are there. Is it clear, Deep, now? There is another what we call tri-state inverter. Z is not 0, man. Z is neither 0 nor 1. It is open circuit. It is disconnection. You have like this. 4 people are there. A, B, C, D. 4 people are there. Okay. You may allow only one below. Remaining are open circuited. They are disconnected from the circuit. That is not 0, not 1. No, don't take this bar and this bar cancels. When enable bar comes, bubble comes, any one of them comes, both comes also. Take it as enable bar only. Its name is enable bar. Don't cancel this bar with inverter. Sometimes examiner may give you like this also. Different books follow different terminologies. Okay. He may give like this or like this. Any case, you take same. No, just it is a representation. Please understand. There is my deep. Deep, it is clear for you? Here Z is a high impedance state, which means open circuit, which generally here in this particular case you are not treating as 0 or 1 also. Sometimes, okay, depends on the logic family. If you want to go little depth, I can say sometimes open circuit may be equal to 1. Okay, sometimes open circuit, yes, in the TTL open collector output, it is treated as 1. Very good. You know that. That is not required. I am not discussing. That is the reason for remaining people don't think like SAR is discussing something with only the. Okay, tri-state buffer is possible. Tri-state inverter is also possible. Enable can be active high. Enable can be active low also. Okay, everybody, is it okay? So let's go back. So finally, from the what is this? Let's start the poll. Forget about extra discussion is more than your question. Actually, examiner framed the question good, but the options you made easy. Otherwise, it could be better. Very good. So my job is easy for this question because 80% gave right answer already. Yeah, this is a previous gate question. That's why I kept it as it is. If I make the options, definitely you know. Vivek, Manjunath, Vipul, Robert, Harsh, Deep, Suraj, Anuj, Amitabh, and Abhinay. Right. So where we are? Right. So today is Saturday. If I cross your 2 hours time, that is 9 o'clock, immediately you remind me, sir, time up. So that I will leave you. Okay. So what is the answer is 4 by 1 marks. It is very simple to understand. Okay. Here your PQRS, your C1, C0, and Y. If C1, C0 is 0, 0, what happens? C1, C0 is 0, 0. This output 0 will be 1, remaining all will be zeros. Okay. Now, if it is 0, you can open circuit this. If it is 0, you can open circuit it. If it is 0, you can open circuit. Only this is 1. Then you can close this path. Then P fellow will come to Y. Okay. Is it okay, everybody? Yes or no? Please tell me, yeah. Similarly, for 0, 1, second line will be activated, remaining all will be open circuited, and you will be getting Q. Next you will get R, next you will get S. That is, it is nothing but indirectly doing the job of S1, S0, 0, 0, 0, 1, 1, 0, 1, 1. It is selecting 1 out of the 4 inputs. That's why it is called 4 by 1 multiplexer. This is implementing 4 by 1 multiplexer using your decoder and buffers. Anyone having doubt, feel free to ask. Don't worry about it. Even everybody understand. Someone have doubt, please ask me, no problem. Okay, done. What happened? Your comment speed is decreased. One more question, one more poll. It is a previous ES question. Oh, nice. If you don't ask doubts, I have two fears. One is happy, you understand everything. Second is people may not be able to understand. Okay. Without tri-state, what do you want to do, man? Manju? In this particular case, only this tri-state is required to make it. Okay. Otherwise, this is a wired logic. You should know at least wired logic. I mean, we should know means this logic family is wired logic. We should know. Then you may be doing with some gates. That's what I said now just now. You understand? Without buffer, if you are directly connected, it's like a wired logic. No? Wired AND gate, wired OR gate. We have discussed it already earlier. So, which of the following? Okay. Logic circuits can perform more code conversions. It's a previous IES bit, I think at ES 12 or somewhere, 10 I think. So tell me the answer. Start the poll. Very good. It happens, Vivek. Robert, Abhinay, Amitabh, Anuj, Deep, Suraj, Bharati, Kuldeep, Nishita, and Manjunath. Right answers. So right answer is 4 by 6. If you have 4 by 6, you take 4 up to 10. You take only 10 outputs. It is like binary to BCD. Yes or no? If you have 16, you are not using all the 16. You use only 10, 0 to 9. It is like a binary to BCD. One example. Use all 16. If you use all 16, what is the answer? It is a binary to hexa. Or you use the 4 by 16 can be used as 3 by 8 and 2 by 4 also. Yes or no? Out of the 4 inputs, you select only 3. Or you select only 2. That is, if you have more size, definitely more conversions are possible among them. So what is the right answer is 4 by 16. It does not require much explanation, I think. Okay, so now I am giving you very good, wonderful question. Okay, get ready, guys. Just let me upload. One minute. Yeah, got it. Yes, adder question is also remaining. Slightly adjust. I didn't make the slide. I am taking from my original PDF. So read the question. Is it possible? I will zoom it. Don't worry. Without zoom, is it visible for you? Yeah, just go through that. If you don't have laptop, may not be visible. Just read these lines. It is difficult to read the lines of the question. That is the problem here. Question is easy. Understanding is difficult. See the figure. 1 minute. I will make a better slide than this. One minute. Yes, just read this. So take your time and read it, no problem. Shall I read? You have a 1 by 8 DMUX with data input D9, D in, and S0 to S1 as the selection inputs or address lines, S0 as the LSB, and Y0 to Y7 are the 8 demultiplexed outputs is to be designed using two 2 by 4 decoders with the enable input E bar and address A0 and A1 as shown in the figure. D in S0, S1 are connected to PQRS, not necessarily in the same order. Okay, so the respective input connections of the PQRSCs. So what he did, he made a 1 by 8 DMUX. What he want is 1 by 8 DMUX using 2 by 4 decoder. What is the meaning of this? Active low. What is the meaning of this? Active low outputs. What is the meaning of active low output, sir? If it is bubble is there here, bubble or bar, anything is there, it is active low. Don't cancel. Someone asked me earlier also. Don't cancel bubble and bar. It is not like if it is zero high. Please let me explain. Only you, right? Wait. I will tell you. See, earlier when it is activated, you got one. Remaining all are zeros now per decoder. You got like this. This is active high. That is when the input line is activated, the output particular corresponding will be high. What is active low? Complement of this. That is all will be by default ones. When you activate, it will become zero. So that is just the inverted outputs. Okay. So I'm explaining it. Now you understand. So terminology of the question is difficult. Question is not difficult. 1 by 8 DMUX is to be made with S0 to S2 are the selection. D in is the data input. That is our I. Y0 to Y7 are the 8 demultiplexed outputs. It is to be designed using two 2 by 4 decoders with enable input E bar and the address lines A1, A0. We use the terminology A and B. Na? Here you used A1, A0. Okay. It can be anything. It doesn't matter. As shown in the figure, D in S0, S1, S0 are to be connected to your this PQRS. Here I should give D in S1, S2, S0. What is the order you need to give here? That is the question. Okay, they can be in any order. What is the order you need to make? That is the question required. Hey man, you understand here, Sushil? In place of P, Q, R, S, you should make this PQRS to D in S2, S1, S0. What is the order he is asking? Whether you need to make in this order or you need to make S0, S1, S2 or S2D in S1, S0. What is the order you want to make? That is the question. Question is clear to everybody. If I explain the question, there is nothing fun in the question. Personally, you should understand examiner statement. That is what required. Get ready. I will start the poll. Okay, just 1 minute. Okay, I will wait. No problem. Right. So let's start. It's a matter of 1 minute if you understand the question. It is a matter of 1 minute to answer this question. I have explained clearly. You should make a DMUX using decoders and this OR gates, whatever may be the extra circuitry, such that it will perform your job. So let me start the poll. If you don't, 1 minute. If you don't know the answer, keep it none also. Very good. So many right answers are there. Amitabh, Anuj, Bharati, Suraj, Nishita, Sushil, Vasista, Kuldeep, Ganesh. Very good. Rohit. So very simple right answer will be D, this one. So let me explain you these things. Let me explain. So those don't understand the question, please understand. You should make a demux using decoder. So here S2, S1, S0 will be how you know this already. 0, 0, 0, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. You tell me here during this first decoder, during this second decoder will be selected. Is it okay for you? Your DIN is the same as enable. This already you know this. Your DIN is nothing but I must be same as enable. Okay. And what is the job required for you? S2 and S0. Those who have not answered correctly, I want comments from them. Up to this, clear or not? So now you see S2 should be like that. When it is 0, it should select one part. When it is 1, it should select one part. Now go back. You see S1, S0. S1, S0 must be common to both decoder or demux. Yes or no? Are they common or not? S1, S0 is the same. So first tell me which two inputs are common. These two. Here one is here. So it is S1. It should be S0. Half of your job is done, man. Okay. So R should be S0. S should be S1. Why R S0, sir? Here 0, 1. Given na order. You should follow that. A not A. Okay. So next, this is the last question for today's class. Okay. Next, you should see one thing. S2 should have one inverter because it is first half it is 0, second half it is 1. So you tell me out of P and Q, which one is having common line, which one is having inverted line. This should be your S2 because when this, you just see here, when this is 0, you will get 1 here. 1 plus anything is 1, 0 plus P is P. Okay, now you see here, just observe, 0 is 1 here. So whenever 1 is there, because it is active Lona, it will be disabled. Based on P, it may be enabled. That information may be transferred. Similarly, just see the reverse thing. If this is 1 plus anything, what is the answer? 1. This 1 will become 0. 0 plus P. P will come here. That will decide whether to enable or disable. But this will be disabled because it is 1. Active Lona bubble is there. Okay, let me complete first, Aditya. Okay, always don't keep in your mind. I want to suggest you one thing. Okay, don't keep any fear in your mind. Like, I may not be able to understand this because it is looking complex. No, you will be able to understand. Don't worry about it. So, is it clear? Now, listen here. I'm repeating this S2 part. S1, S0, I hope everybody understands. S2 should be like this. When it is 0, it should select the first decoder. When it is 1, it should select the second decoder. So which one can do that? Here, if you take P equal to S2, what is the problem? P is common now for both of them. It cannot do that job. P is the same for both the decoders. So which can do that job? Q. When Q is having one inverter going to this. So if it is 0, here 0 comes, here 1 comes, 1 plus anything OR gate output is 1. This will not be selected because here when 1 comes, it will be disabled. And 0 plus P will be P, and this will be selected based on your P. If P is 0, that it may be enabled and transferred that 0 and all those things. Okay. So similarly, you can understand or analyze when is this everybody accepted or not. Your Q is equal to S2. Only S2 can be Q because only S2 is having this inverter. Okay, S2 cannot. S2 is the required condition. First half 0, second half. Anybody having doubt, please ask. Q should be S2. It should be S not S1. Obviously this is DN. Yeah, okay, 1 minute. Yeah, ask me. Anybody having doubt, please ask. Is it clear to everybody? It's not a difficult question. Buffer output is same as input. Sushil, buffer is the circuit where output is same as input. But in our networks, it may be different. Different means output same, but input impedance is high. Okay, very clear. Good night. You don't want that adder question, people. Yeah, anyway, you have only raised that doubt. Okay. So if it is clear, let me clear you one thing, one doubt earlier given. Okay, earlier one correction of the previous class. Correction of previous doubt session. Okay, what is that correction, sir? Let me clear that, we can end the class. Bubble is not there, then it is not possible. Okay, anywhere you need inverter compulsory. Then if this bubble is not there, then circuit may change, but this inverter should present compulsory. Okay, so where we are, right? So earlier, what I told here, worst case delay is in the above case. That problem, let me upload that. Okay, this question. Okay, answer everything is same. I analyzed one more thing. Worst case delay as n minus 1 TC plus maximum of TS comma TC. This is not applicable here. Yeah, I will provide Deepak Monday. Yeah, 15 nanoseconds problem. Answer is 50 nanoseconds only. That is correct. Okay, answer 50 nanoseconds correct only. Okay, we have discussed that already well in the doubt session. I calculated worst case delay by using this formula blindly. That is wrong, I'm saying. Why? Because here you are giving this carry, okay, to this, and this carry is given to this. Okay, so to generate sum, it requires 40 nanoseconds. To generate carry, it requires 45 nanoseconds. What I want to say is when this comes here at 45 nanoseconds, okay, by that time it is already ready now. By the time this is already ready, this 20 nanoseconds part. So the remaining is 25. So here you should not count 45 plus another 45. Here it should be what? Worst case I am saying. It should be 70. Okay. So this is what I want to explain. I mean, I have given their wrong analysis. So please understand, because the AXRB will, because this formula is applicable when box is given or when your circuit is containing 3-input XOR gate. Here 2-input XOR gate followed by another 2-input. Na, this job is independent. This job and this input will come independent. This XOR will come independent of carry. Na, so this can come initially. So depending on the carry formula you are using, you can use this figure equation or not. If nothing specified, blindly you can use. But internal figure is like this. Let me write somewhere. Okay. Yeah. If carry equal to AB plus BC plus AC. Okay. Or A XOR B into C plus AB. Okay. In that, this first one and second one, this 1 and 2 independent of carry, because the AX or B can be performed without carries, AB can be performed without carry. So your carry will depend on this end operation. That total answer will depend on this end operation and OR operation. Okay. By the time these two are already performed, that's what I want to say. So blind answer may not be applicable here also. He has not asked that, but generally I gave the answer as 180. That is wrong. Here extra delay is how much added? Only 25 every stage. Everybody understand or not understand? I'm saying earlier we have used the formula na, n minus 1 times carry delay 45 plus maximum of 40 and 45. That is not applicable in this question, because he has given the internal circuit for us. You understand that these inputs are ready. These inputs are ready before applying carry itself. Okay. So carry requires extra. After applying the carry, you require extra 25 only for the second stage and third stage, not like the first stage. Then maximum delay you want. So first case it is 45, second case it is 25, next case it is 25. Okay. First stage, second stage, third stage, and fourth stage maximum of 25 and some. 25 and 20 actually. That will give you 120 nanoseconds. Okay, because this is, it is not 3-input XOR, na. It is a 2-input XOR. That AX or B, first this part will be done easily. Only this part is depending on carry here. So you should take care of this part only. So worst case delay in that case will be 120 nanoseconds. No, everything total delay only. Okay. So only sum you require 115 is correct, right? So delay means generally we should take all the output should be ready. So so I promised you to leave early, but today also 7 minutes fast. So everybody is okay, then I can end the session. I will 1 minute. Individual doubts I will take, don't worry. Amitabh and Anuj, don't worry. Remaining people, good night. Good night. Enjoy your weekend. So we'll meet again on Monday with more energy. Thank you. Thank you very much. Good night. Please rate the class after this. Thank you. I mean that like button only. So thank you. Good night. Good night. Now, anyone having doubt, just you can ask. No problem. Who is that? First, Amitabh ka doubt kya? In this question. Yeah, what is your doubt, Amitabh? I kept D in like this. Tell me your doubt, Amitabh. I'm happy to explain. Dn is equal to 1. What happens? So Dn is equal to 1. Okay, this is also 1. This is also 1. Both will be disabled. That is your doubt, right? Yes, very good. Yes, Vivek, thank you. Okay, in this case, both will be disabled. When both will be disabled, all will be ones. Okay. Yes, Swapnil, generally, if internal structure is not given, we can blindly apply that formula. So now, Amitabh, still it is working like a decoder or not? Maybe is it working like a demuxer? Definitely working like a demuxer. So here, based on the selection inputs, so no. That's what I am saying. Your DN is transferred or not? Tell me. Your DN is transferred or not? That's all. So based on the selection inputs, if it is 101 at 5, you check. You may have the doubt, sir. How, sir? All are ones now. What is the use of 5, sir? Go back. Go back. Yeah. I know your doubt. Okay. I am taking this Dmux example. If I equal to 0, what is this row, man? All zeros, because it is active high circuit. If it is active low circuit, all ones will come. Clear over your doubt? That particular line will get information. It can be 1 or 0. That is your require. All may be ones. It doesn't matter for us. Okay. So this line may be becoming 1 and 0 to satisfy. That particular line definitely it will change based on your DN. So very good. Actually, I thought of explaining that doubt, but you got that doubt. I am very happy. Where is that question? Yeah. Okay. So if Dn is 0, that line becomes 0. If Dn is 1, that line becomes 1. That is our job is getting done. Right. Any other questions? Anuj, someone asked me, sir, how to choose Q as S2, both PQ. Wait. How to choose Q as S2 since both P and Q goes to decoder. That's what I said, Anuj. P is directly going, but Q is going through inverter. It makes sense or not? P is working like a data line. It is common for both of them. Q is liking like a selection line, which will select based on whether it is 0 or 1. Yes, encoder and decoders are called as code converters only, Swapnil. One minute, please. One by one. Anuj, your doubt is cleared. Okay, you are done. Now, Pupul, what is your doubt? Second carry of BCD adder, will it be 0 when sum is less than 9, but 1 when sum is greater than 9? Second carry is always 1, sir. I didn't understand your doubt properly, people. You do one thing, just message me in Telegram, we can see there. No problem. Okay. I mean, one example you send me, then I can visualize it. What is your doubt, Bharti? Second carry will be considered when you are having carry from the MSB, not auxiliary carry. Simple rule. Okay. People, just one simple rule is take, you frame your own rules by taking, yes, sequential in the next class, but I will complete this part. Whatever encoders is there, ROM is there, everything is completed. Then I will start sequential. Okay, Swapnil. I don't leave that left over. Okay, people. Second carry will be coming when your second, after second addition, or whenever you are adding 6 to the next number, then if it is greater than 9, greater than your range. You just take few decimal examples itself, you can derive your own result, people. Okay. If it is not cleared, also no problem. Just ask me in the Telegram also. I am okay. Okay. What is your doubt, Bharti? How to take ones for P bar plus Q? Okay. Tell me. You only tell me P bar plus Q. 1 bar is how much? P bar plus Q. You tell me 1 bar plus 0. You are there or not, Bharti? 1 bar is 0, na? 0 plus 0 is 0. P bar plus Q. Again, here 1 bar is 0 plus 1 is 1. 0 bar is 1, 1 plus 0 bar is 1 plus 1 is 1. 0 bar is 1 plus 1, 0 is 1. Is it clear? P bar plus Q. Maybe little confused you maybe. Just P bar plus Q. P bar plus Q. P bar plus Q. P bar plus Q. Is it clear now? Fine. Thank you. Thank you very much. Let's end the class for today. Nice. Have a nice weekend. We'll meet Monday, same time. Thank you very much. Monday, don't miss the class. So sequential will be started. Basic part is very important. Thank you very much. Good night. Thank you. Thank you.